All right, we are continuing with Unit 7, Differential Equations. Today is Lesson 2, Solving Differential Equations. I kind of alluded to some of the skills that we need today in our last lesson in Lesson 1 when I started to separate dy's and dx's. So students will be able to solve differential equations by using integrals and an initial value, if given. Your differential equation is written as dy over dx. And we've, up until this point, kind of treated, well, no, I guess we separated them at other points too. Dy and dx as one thing, but truthfully, they're two separate things. It's called your differential. And you can separate them. We did that a little bit with errors, a little bit, and kind of rate of change, not so much rate of change, but when we found the error in the area as compared to the radius, we separated them out. Your initial value equations, you can find the curve through a specific point xy, and that point xy is the initial condition, and that's what we were discussing last lesson. So example 1, we want to solve the differential equation. So in the box on the right are the steps. 1, isolate dy dx. 2, put all the x terms together and all the y terms together. 3, take the antiderivative of both sides. 4, solve for y. And 5, plug the initial conditions in to solve for c. So if dy over dx is equal to x over y, you want to get everything on the same side that's the same variable. So I'm going to multiply both sides by dx. So dy is equal to x over y dx. Then I have to get this y to the left-hand side. So I'm going to multiply both sides by y. So y dy is equal to x dx in this case. It's kind of like we just undid a cross multiply problem, or we did cross multiply. Now we're going to integrate both sides. So the antiderivative of y is y squared over 2. There is a plus c there, but I know we talked about this in the last lesson. The integral of x is x squared over 2 plus c. Now technically these are two different constants. If I subtracted the one from the left and brought it over to the right, it's still a constant. So we don't really use the one on the left, we just leave the one on the right. So that's what it looks like. And then you want to solve both sides for y. So how do I solve this for y? I'm going to multiply it through by 2. So this is y squared equals x squared plus 2c. But a constant times 2 is still just a constant. So I have y squared equals x squared plus c. Then I'm going to take the square root of both sides. So y is equal to the square root of x squared plus c. Now, technically, I take the plus or minus because we took the square root of both sides. There you go. I wasn't given any initial conditions, so I don't have to worry about that in this case. Good. Example 2, solve dy dt equals negative t over y. So you want to look for that initial, it's a Monday, can you tell? You want to solve for y. They didn't give us an initial condition in this case, but that's okay. So dy over dt is equal to negative ty. I'm going to multiply both sides by dt. So dy is equal to negative ty dt. I'm going to divide both sides by y. So I have dy over y is equal to, this is a t, good grief, negative t dt. There we go, that's correct. So now we have to integrate both sides in order to get rid of that dy and that dt. So what's the antiderivative of dy over y? Well, it's natural log of y. What's the antiderivative of negative t? Negative t squared over 2. And remember, keep the plus c with that independent variable side. Keep it with the x or with the t. Now, to solve for y, we have that natural log in the way right now. So what are we going to do? We're going to introduce an e on both sides. So y is equal to e to the negative t squared over 2 plus c. Yes, this is good, but we can take it one step further. Think back a little bit. If you had x squared and x cubed next to each other, that would become x to the 5th, right? Because it's really x to the 2 plus 3. Well, this is what we have right here. So we're going to take it back. We're going to break that e apart to two e's. So y equals e to the negative t squared over 2 e to the c. But e raised to any constant is still just a constant. So y is equal to c e to the negative t squared over 2. Now when you write it like this, it's clear to see that it's an exponential growth or decay. And in fact, this kind of looks like that PERT formula. Remember that PERT formula from ages ago? Your initial amount, your E, your rate, your time. This is just a variation of that. No initial condition, so I don't have to solve for C. Example 3, solve the initial value problem when dy dx equals sine of x when y of 0 equals 2. So like in the last lesson, remember we chatted that this is x and this is y. So this is really just another way to write the ordered pair 0, 2. So if dy over dx is equal to the sine of x, you can still separate your variables. Dy equals sine of x dx. Integrate both sides. Remember there's a 1 in front of that dy. So this becomes y equals, the antiderivative of sine is cosine, but what am I missing? A negative sign. The derivative of cosine is negative sine, but if I want a positive, I need to include that negative to balance out the negatives, plus c. So my initial value is 0, 2. So 2 is equal to negative cosine of 0 plus c. What's the cosine of 0? Remember your unit circle. This is the ordered pair 1, 0. So cosine of 0 is 1. So 2 equals negative 1 plus c. c is equal to 3. So put it all together. Y equals negative cosine of x plus 3. Solved your initial value problem. So now we have the specific solution instead of just the general solution. Example 4. Solve the initial value problem dy dx equals 1 plus y squared times e to the x when y of 0 equals 1. Remember, ordered pair, this is really 0, 1. dy dx is equal to 1 plus y squared e to the x. So remember, separate your variables. I'm going to do this all in one step this time. dy plus 1 over 1 plus y squared is equal to e to the x dx. Then you want to integrate each side. In this case, I think the easier side is the right-hand side. What's the antiderivative of e to the x? It's e to the x plus c. Now, on the left here, we have this dy over 1 plus y squared. What does that remind you of? Should be inverse tangent. So this is the inverse tangent of y is equal to e to the x plus c. Now, do you have to solve for y every single time? You don't have to. And in fact, in this case, I think it might be easier to solve for c before we solve for y. So inverse tangent of y is equal to e to the x plus c. So I'm going to say inverse tangent of 1 is equal to e to the 0 plus c. E to the 0 is 1 plus c. Inverse tangent of 1. So in your unit circle, where's tangent equal to 1? Or do you have a y over x that will give you a 1? Happens up here at pi over 4. So this is pi over 4. So c is equal to pi over 4 minus 1. So if I put this one together, I've got inverse tangent of y equals e to the x plus pi over 4 minus 1. Excellent. All right, example 5. This time, instead of giving you the first derivative, I'm giving you the second derivative. So d squared y over dx squared is equal to x to the negative 3 over 2. I feel like we did this one kind of similar the other day. D squared y equals x to the negative 3 halves dx squared. If we integrate both sides, I would go up to the first derivative level. If I add 1 to negative 3 halves, I get a negative 1 half divided by negative 1 half dx plus c in there. How do I want to do this next? First derivative at 4 is equal to 2. So that y value is the 2. 4 to the negative 1/2 over negative 1/2. That dx in this case, you don't have to put anything in there. That's telling us what variable we're doing this with respect to. And here's my plus c at the end. So this becomes 2 equals, if I divide by negative 1/2, that's really the same thing as multiplying by 2, over the square root of 4 plus c. So 2 equals negative 2 over 2 plus c. 2 equals a negative 1 plus c. So 2 is equal to negative 1 plus c. 3 is equal to c. So if I put that first derivative piece together, their first derivative is negative 2 over the square root of x plus 3. Now, if we integrate this one more time here, dy equals negative 2. I guess we want that still in the top. X to the negative 1/2 plus 3. You still have your dx's on the right-hand side. Now, I'll be honest, I'm not exactly sure where I want to write that. I guess on the end of everything. That this is all with respect to x on the right-hand side. All right, so now if I integrate, I've got y is equal to negative 2x to the 1/2 divided by 1/2, because we added 1, plus 3x plus c. So y is equal to a negative 4, x to the 1/2 plus 3x plus c. I think they gave us another ordered pair up here. They did. They said 0, 0 for the original. So 0 is equal to negative 4 times 0 to the 1/2 plus 3 times 0 plus c. C is equal to 0. So y is equal to negative 4 square root of x plus 3x plus c. All right. Nope, not plus c. We just said c was 0. It's a Monday. All right, there we go. I think we've got it. So separate. X is on one side, y is on the other side. Integrate both sides. If they give you an initial condition, go through and solve for c. Good job.